tell you about a place somewhere up a New York way where the... Hey everyone, and welcome to today's lesson about measuring segments. To find the distance between 2 points, we need to find the absolute value of their coordinates. Alright, that looks like the absolute value of A minus B in this situation. Alright, so to calculate the distance between these 2 points, we're going to do the absolute value of -9, which is the coordinate of A, minus the coordinate of B, which is 3. The absolute value of -9 minus 3 is the absolute value of -12, which is 12. Alright, it's really important that we're talking distance. We can't have any negative numbers, and that's why we make sure to do the absolute value. Well, we've got the number line in front of us. Let's just try another example. How about we find the distance between the points G and E? Alright, well, to find the distance between points G and E, we'll do the absolute value of the coordinate of G, which is -5, minus the absolute value, minus 7. We'll take the absolute value of, what do you know it? -12, which becomes 12. So the distance between these 2 points are actually the same, even though they are on different locations on the number line. Pretty cool. Alright, let's keep moving. Now the ruler postulate allows us to say that every number can be paired with a real number on the number line. So every point is paired with a real number, and this gives us those coordinates that we were just talking about. So if we're given some points along the number line here, we're looking at all negatives, we can find the distance between SO. And remember, when I simply have the letters of points right next to each other, that means the distance between. Okay, so if I'm looking to find SO, I can do the absolute value of -30 minus -25. I've got those negatives next to each other. That tells me to do addition. This is the absolute value of -5, which is 5. Now, if you looked here and just noticed that the space between 30 and 25 is 5, that's fine too. We can do that with SU. If we look from S to U, I go from 30 to 15. We're moving 15 units there. Alright, SD, the distance from S all the way to D, I go from -30 to 0. That means I had to have traveled 30 units. And then from O to U, I went from -25 to -15. That means I had to have moved 10 units. Alright, let's kick it up a notch. And let's say that the distance between U to N and N to D is the same. And we're going to talk about this in a moment, but that means that N is the midpoint. Okay, in other words, N is right in the middle of U and D. So if I look, the distance from U to D is 15 units. So if N is right in the middle, we've got to divide that by 2, and we get 7.5. Now be very careful. We are on the negative side of the number line, so the coordinate of N must be -7.5. Alright, moving on to the next page. Be sure that you're on page 14 in the packet. We're going to talk about what's called the segment addition postulate. Alright, the segment addition postulate says that if I've got 3 points that are all on the same line, or they are collinear, and B is between A and C, then I can add segment AB to segment BC, and I'll get the full AC. So I'll kind of draw a picture of this situation. Alright, I've got a segment. B is in the middle of AC. Okay, so this segment AB added to BC is the whole segment, and we can use that to help us solve some problems. Alright, let's look at the given information in number 7. PQ, R, and S are collinear, meaning they're on the same line. Alright, PQ is 3 and let's label our picture. It's essential to label the picture. PQ is 3. PR, so this distance all the way from P to R is 10. And R to S is 6. Okay? We want to know what's the distance from Q to R. Well, if the distance from P to R is 10 and P to Q is 3, we just got to find the difference. So we're doing 10 minus 3, which would be 7. And our distance from P to S, all right, that's the entire distance of this segment. All right, since I just found out QR was 7, I can add that in. And I've now got 3 plus 7 plus 6 gives us a total of 16. And there we just used our segment addition postulate to find the distance between PS. Okay, still on page 14 now. It's your turn. Go ahead and pause the video and try question number 8. All right, let's check those answers. If JV is 16, so we've got from J to V, that's 16, and J to N, that's that whole deal, is 21. How can we find NV? Well, that's the difference between 16 and 21. So we've got a grand total of 5 there. Now, I'm going to wipe this clean because we've got some different numbers to put on our line. And we're trying to find if JV is now 20 and JD is 11 and now DN is 13. How can we find this little piece here? Okay, well, if we find the difference between 20 and 11, I now know that's 9. Okay, and now I know the distance from D to N is 13, so I can find the difference between 13 and 9, and I get 4. Excellent. Now this last one was a lot of fun because it gave us an expression for each one of these distances. And it gives us an expression for JD, an expression for DV, and one for VN, and tells us that the whole deal is 32. This works out nicely now because I know I can add 2x and 3y plus 7 minus y plus 9x minus 2y. Right? That was each one of these segments added together, and they all add up to be 32. Okay? Now when I combine my like terms, I've got 2x and 9x leaves me with 11x. I've got 3y minus a y gives me 2y, and I take away another 2y. Boom, all these y's are now gone. Okay? And I'm left with a 7. So 11x plus 7 equals 32. Go ahead and subtract 7 from both sides, and 11x equals 25, and you divide both sides by 11, and you are going to get a decimal, and that's okay. We find that x is about, we should use my approximately, is about 2.3. Cool. Moving on, let's talk about that midpoint again. The midpoint on the coordinate plane, okay, the midpoint, and when I'm talking about the coordinate plane, that means I'm using ordered pairs. If I have endpoints x1, y1, and x2, y2, I calculate the midpoint by adding my x coordinates and dividing by 2, and then adding my y coordinates and dividing by 2. Okay? When you look at an example, I've got endpoints negative 8, 4 and 5, 5. So I'm going to go ahead and add my x coordinates. That's negative 8 plus 5 over 2. And then I've got 4 plus 5 over 2. When I actually do that addition, I end up with negative 3 over 2, or negative 1.5 for my x coordinate. And then 4 plus 5 is 9 divided by 2. So 4.5 for my y coordinate. Alright, now it's your turn. Go ahead and pause the video and calculate the midpoint in question number 2. Let's check your answer. Add your x coordinates. That's 0 plus negative 10 over 2. And then 0 plus negative 3 over 2. It gives me negative 5 over 2, which is negative 2.5, and negative 3 over 2, which is negative 1.5. So there is the coordinate of the midpoint of those two endpoints. All right. Last little bit here, let's talk about finding the midpoint, or using the midpoint rather, to find some distances along a segment. I'm given that ST is equal to 3x plus 3, and TU is equal to 2x plus 9. Okay? Now there's something really important on this segment, and it's these two small tick marks. These two small tick marks tell me that segment ST is congruent to segment TU, meaning they have the same measure. So since they have the same measure, I can go ahead and set these expressions equal to one another. So 3x plus 3 is equal to 2x plus 9. Going to go ahead and solve for x now. So 3x equals 2x plus 6. I'll subtract 2x from both sides. I get x equals 6. Okay, I'm asked to find the value of ST and the value of TU. All right, so I'm going to plug in 6 for ST. So 3 times 6 plus 3 is equal to 21. Okay, and the beauty of this is that since you know these two segments are the same, I also know that TU is equal to 21. All right, you try. Go ahead and pause the video and let's find the distance of ST and TU in number 20. All right, you were able to set these expressions equal to one another since we know that their measures are the same. All right, you subtract x from both sides, add 6 to both sides. We find out that x is equal to 3. That means that ST must equal 6. So SU will be 6 as well. Hold your horses, folks. That's why I've got to be careful here. Ask for the value of SU, which is the entire distance. So that's 6 plus 6, which is 12. Got to be careful with those. All right, here's your next steps. You're going to complete pages 13 to 16 in your packet. And when you're feeling confident, go ahead and take that Math Excel Quiz 7.2. That's all for now.